So what are magic squares? They are a square matrix with n rows and columns. Each entry contains an integer from 1 to n squared. What makes them magic is that every row, column and diagonal adds up to a specific magic constant. There are an infinite amount of magic squares possible. Only one for a 3x3 square, but it jumps up to 880 for a 4x4 square. Squares beyond 6x6 haven't been counted yet. Magic squares might seem inconsequential, but their impact on mathematics has not been insignificant. Their most compelling aspect, however, is their demonstration of the simple beauty of mathematics.
There is a legend that claims that the first magic square was discovered by the Chinese Emperor Yu, who was walking along the Yellow River when he noticed a tortoise with a unique diagram on its shell. The Emperor decided to call the unusual numerical pattern Lo Shu, which is the earliest magic square on record. It is a 3x3 magic square, but instead of numbers it is represented by patterns. Magic squares have been around for over 4,000 years and have been used in many different cultures. They are believed to be even used for astrological and divine purposes and to provide good health and protection from disease. They can be traced back to ancient China, Egypt and India, but the first well-known magic square was a 4x4 which is depicted in 1514 by Albrecht Dürer.
Throughout history, magic squares have been a recreational pastime of many mathematicians who study other areas of maths. Belgian mathematician Maurice Krejcik, who was known for his theory of numbers, also developed techniques of constructing squares of odd and even order during the early 1940s. In 1942, he published Mathematical Recreations with a chapter dedicated to magic squares, their transformations and their composition. A second method of generating magic squares of odd order, known as the lozenge method, has been discussed by English mathematician John Horton Conway, who is better known for his work in number theory, knot theory and coding theory. Conway is also credited with the Lux method for constructing squares of singularly even order. Mathematicians are still being fascinated by magic squares today, such as Walter Trump, a German mathematician, who has worked alongside Christian Boyer to develop the first known magic cube in 2003.
Magic squares are one of the beautiful examples of mathematical objects with several real-world applications. Physical applications with respect to magic squares was first explored in 2001. For example, interpreting them as arrays of point masses, or as electric charges to connect with a center of mass, moment of inertia, electrical multipole, electrostatic potential, and the list goes on. One of the very first applications of magic squares, as mentioned before, is center of mass. It was found that the center of general magic square is the point where all of the mass of the given magic square is concentrated. Thus, when a magic square is supported at its geometrical center, it will remain in static equilibrium. Obviously, not all magic squares are balanced in this nature, but it is a special property of some magic squares. Magic squares have also continued to develop from their inception, as there is now things such as magic circles, stars, hexagon, and again the list goes on. Another area of mathematics which has been enhanced by magic squares is matrices, as it has allowed certain spectacular properties and examples of matrices to be found, hence the name magic squares.